Dear students, we see real-time system, unit 4. So in the unit 4 we will discuss about the structure of the real-time system. So what is an operating system? Before seeing this real-time operating system, we must know what is operating system. An operating system is an interface between the user and the computer system. An operating system has a kernel function, so the file management function and other important functions. So based on the application, we have different kinds of operating system. So some of the operating system we are using for computer system, and some of the operating system we are using for mobile, and embedded system we are using real-time operating systems. So here you can see the hardware. In between the application software we have operating system, and the above this application user. So what is operating system? It is the software layer between the hardware and the application software. It is a software layer between the hardware and the application software, which has direct access of the hardware. You can see here it is a direct access of the hardware. It manages the hardware according to the predefined rules and the policies. So they hide the hardware complexity from the application software. So it can offer multitasking resources and the data management. So it is a software layer between the hardware and the application software. So what is, you can see the examples of the operating system. So Microsoft Windows, Linux, Mac OS, Android, iOS, embedded system. These three are used for PC, and these two used for the mobile application, and this is for embedded OS is for the embedded systems. So what is a real-time operating system? A system is called a real-time system when we need a quantitative expressions of the time, that is the real time, to describe the behavior of the system. So RTOS are designed specially to run application with a very precise timing and a high degree of reliability. So RTOS means real time plus operating system, that is called the real time operating systems. So here the real time is one must process the information and produce a response within the specified time. Otherwise you will get a severe consequences including failure. That is, in a system with a real-time constraints, it is no good to have the correct action or the correct answer after a certain deadline. If you give a correct answer after the deadline, it means that it is failure only, right? So a system is classified as a real time if it is required to complete the work on a time constraints. So it does not mean that a system must meet some timing deadline. It is not a timing deadline. So I can say the example for the real-time lifetime air traffic controls system. So network multimedia system, the command control system, the multimedia systems, okay, the virtual reality or the game stuff, many things is there. Okay. So we can see this typical components of real system in the computers. So you can see here the environment, we can remote monitoring system. All these data are go to the database, and it is displayed in the, and you can see here the real-time clock is there, and the engineering system is interfaced with the algorithm of the digital controller. So it should work in the, it is a operator console. You can see the interface. So it is based. So it is completely depends upon the real-time clocks. Okay. So any system where timely response by the computer to the external input condition is vital is a real-time systems. So it should meet the deadline, that is timeline. So for example, we can consider the temperature of the chemical reaction chamber. So it attains a certain predetermined temperature. Okay, let us consider 250 degrees centigrade. The system automatically switch off the heater within the predetermined time interval. So that is within the 30 seconds. Okay, it has to switch off it within the 30 seconds. So the time value is very important. That denotes the reading of some physical clock present in the plant automation system. Okay, so it should meet the deadline. So here the deadline. What is deadline? A real-time computer system must react to stimuli from the controlled object or the operator within the time interval dictated by its environment. So that instant which result is produced called deadline. Okay, so here the deadlines are hard deadlines and the soft deadline. The first one, the chemical, is called the hard deadline, and soft deadline, I can say, suppose you are going for the library, right? We are using the library software. So after a book inquiry, the book command is given by the user. Details of all the matching books are displayed by the software. So this is, it will not affect anything. So this is called the software deadline. Okay. So the another one is complete the task. That is, within the deadline you have to meet the way to complete the task. Okay. So accurately and estimate within the deadline. So hard real-time system. So if the job must never misses its deadline, then the system is called the hard real. It should never miss out the deadlines. Okay. Hard real-time systems, every deadline must be hit. Okay, must be hit. So in a real system, if the system fails hit the deadline, even once the system is said to have failed. Okay, that is, so okay, we can say the aircraft, nuclear reactor control, it should meet the deadline. Otherwise, we have to see, definitely loss is very high. So what is soft real-time system? If the sometimes deadlines can be missed occasionally, acceptable. It is acceptable with a low probability, then the system is called a soft real-time system. So in a soft real-time system, even if the system fails to meet the deadline one or more than once, the system still not considered to have a fail. So that is example we can give multimedia internet access. So these are about this introduction. So we can see here the example, the car and driver is the example. Driver is the real-time controller, car is a control process, a road is the operating environment, mission is to, what is the mission? Mission is to reach the destination. So how to measure this performance? It is time to reach the destination under the various road, all of you know the road conditions. It reach the destination under various road conditions, and your driver should safely drive this. Safety is very important. Safety of the driver, even if the destination is not reached. This is another task. The task deadlines are not constant. The task deadlines may not be constant. Varies with the operating environment, and writing a formal specification and relating with this very difficult one. So now, so what are the issues we are going to face when we go for the real-time computing? So research area covers computer architecture, fault-tolerant computers, networks, embedded system, standards, digital communication, operating system clock synchronization. So for example, when you talk about a task scheduling, for normal system, the goal is fairness to all the tasks. So it is how we are going to complete the task within the specific time period. So we may use this round robin scheduling. So that is the operating system already told you you can do the multitask. So when you see this multitask, generally you can say that at that time it is performing, or suppose we are using the computer, you are using your laptop, right? You can play the video and you can listen the audio, and you can also surf the net. So all these things you can do simultaneously, but it is not like that. So it will have some time quantum. So that how the time quantums are utilized, that is called task scheduling. We have to give the proper scheduling, how we are managing this task. So we can use the round robin scheduling also. For real-time system, you have to meet the deadline for critical high priority task is the goal. You have to give the high priority. So based on the arrival time or based on the priorities. So we'll discuss later. The task execution time should be predictable in the real time. It should be predictable system. Okay. For a cache based real time system, memory access times varies.